Hello everyone, this is Subhashmita Majumdar from IIPS DAVV Indore, and here I am to give the NAD internal question solution. NAD is a subject that is numerical analysis and design. So starting with the first question, we need to develop an algorithm or flowchart or Python code or C routine or MATLAB code for solving following system of equations to find out the value of x and y for the given equation for the given values of a, b, c, p, q and r, and assuming that all these values are non-zero. So these are the set of equations that have been given to us. So starting with the solution, first the logic part that leads to the algorithm is these are the given equations, and from equation 1 we get x equals to c minus by upon a, which is our equation 3, and substituting this value of x in equation 2, that is in this equation, we get p into c minus by upon a plus qy equals to r. Or we can also rearrange the equation and write it as q minus pb upon a into y equals to r minus pc upon a, which is our fourth equation. Thus, if we compute q minus pb upon a and replace the value of q by it, and similarly compute r minus pc upon a and replace the value of r by it, so we have the equation as qy equals to r, which can also be written as y equals to r by q. So we now substitute the value of y in equation 3, that is in this equation, and we get the value of x. So algorithm for the same is, we need to first read these 6 numbers, that is a, b, c, p, q and r, and provided that these are not non-zero values, then we compute q minus pb upon a and replace the value of q with it. Similarly, we compute the value of r minus pc upon a and replace the value of r by it. If q equals to 0, then write no solution, because like you can see that if q becomes 0 here, then the value of y will tend to infinity, and therefore we stop. But if the value of q is not 0, then we continue with the algorithm and calculate the value of y as r by q, and then we find the value of x as c minus by upon a. Then we write in the values of x and y as answers and stop. Then heading for this next question, we need to dry run the algorithm that we have developed for calculating the value of these equations that has been given to us, that is ax plus by equals to c and px plus qy equals to r. So here the values of a, b, c, p, q and r have been given to us. So we need to give the answer correct up to 4 decimal places using floating point computation and illustrate the situation of ill-conditioned equation, and the change in coefficient q, which is equals to 2.6060, and the situation why we need to explain that why this kind of a situation has arisen. So assigning the values is, I have assigned the values of a, b, c, p, q, r that has been given to us in the question, and then I have normalized these values for floating point computation. So a equals 2.2500 E1, b equals to 0.5200 E1, and similarly these all these values has been normalized. So heading for the second step, since we are actually dry running our algorithm, so the second step says that q is equals to pb upon a. So by calculating this value pb by a, q comes out to be 0.2606, and similarly the value of r has been calculated as pc upon a, which comes out to be 0.1192. Since q is not equals to 0, like you can see that q is not equals to 0, so we continue with our algorithm, and y is substituted as r by q. So the value of y comes out to be 1.666 E2, and the value of x is calculated as minus 0.3217 E2, and then we write the values of x and y, and the algorithm stops here. So when the value of q is changed to 2.6060 on calculating values of x and y with changed value of q while all other variables are kept same, x equals to minus 0.2352 E2 and y equals to 0.1250 E2. Thus, a change in one coefficient by less than 1 has led to a change of more than 30% in the values of x and y. Such a problem is said to be ill-conditioned. Reason as to why this situation arises is that in this case, the reason for this large sensitivity is due to the fact that the straight lines representing the two equations are almost parallel, and a slight change in the slope of one of the straight lines drastically changes their point of intersection, which is the solution of the equations. Now heading for the second question, we need to write an algorithm to evaluate the polynomial. This is the equation of the polynomial that has been given, which can be alternatively written in this form. So heading for the solution, this is a given polynomial which is called as the straightforward determination, but the algorithm is rather based on this method which is called as the nested parenthesis method. So I have actually solved this straightforward determination and have depicted that how this has resulted into the nested parenthesis method. So the algorithm is as follows. Read x comma n for I equals to 0 to n in steps of 1. Do read ai, and for p is replaced as a of n. For I equals to 1 to n in steps of minus 1, we do p is again replaced as a of I minus 1 plus xp. We end the for loop, write the value of p, and the algorithm stops here. Now heading for the next question, we need to obtain the recurrence relation for dividing a polynomial px and write algorithm for corresponding polynomial division by x minus r. So starting with the solution, for illustration of the formulation of recurrence relation, we consider the problem of dividing the polynomial. This is the same polynomial that we have used in the previous question, which is divided by x minus r. So like you can see that the division has been depicted as follows, and we call the reduced polynomial as like bn minus 1 x to the power n minus 1 plus bn minus 2 x to the power n minus 2 plus up to b0. Then equating the coefficients of the above polynomial with the quotient obtained by division above, we get this is the quotient that we obtain in the above division. So we have bn minus 1 equals to an, bn minus 2 equals to an minus 1 plus ran equals to an plus 1 plus rbn minus 1, and bn minus 3 is equals to an minus 2 plus ran minus 1 plus ran equals to an minus 2 plus rbn minus 2. So if we formulate a generalized equation, we have bn minus I plus 1 is equals to an minus I plus rbn minus I. Now the algorithm for the same is, we have a for loop here that is starting from I equals to 0 to n in steps of 1 that reads ai. Then bn minus 1 is substituted as an. For I equals to 1 to n minus 1 in steps of 1, we do bn minus I plus 1 which is equals to an minus 1 plus rbn minus 1. We end the for loop here, and again we have a for loop to write the value of bi, that is from that starts from I equals to 0 to n minus 1 in steps of 1. Here we end our for loop and hence the algorithm ends. Now heading for the next question, we need to calculate the value of the polynomial for x equals to 4.0110 using floating point arithmetic with 4 mantissa using two approaches. One is the straightforward determination and second is the nested parenthesis method. So this is the polynomial that has been given to us, that is x cube minus 4x square plus 0.1x minus 0.5. So using the straightforward determination, we just substitute the value of x in the given polynomial, and thus we get the value as 0.781 e minus 1. While in the nested parenthesis method, we take out x common in the successive steps, and here I have depicted that how you calculate in the nested parenthesis method, and finally we get the result as 0.1846e2. Now we need to calculate the relative error, which is calculated as E calculated minus E actual upon E actual. So E calculated is actually the error that we have in the nested parenthesis method, that is 0.846e2, and E actual is the one is the error that we have in the straight forward determination, which is equals to 0.000781 e to the power 2. So the error that we get is 0.9957. Now heading for the last question, we need to develop an algorithm or flowchart or Python code or C routine or MATLAB code to find the cube root of any number using bisection, false method or secant method or successive approximation method. So what I choose is the bisection method. So let us first know what is bisection method. In this method, we begin the iterative cycle by picking two trial points which enclose the root. 2 points x0 and x1 enclose a root if f of x0 and f of x1 are opposite signs. We now bisect the interval x0, x1 and denote the midpoint by x2, so that x2 is equals to x1 plus x0 by 2. So the algorithm is as follows: x0 and x1, which are the starting two values which encloses the desired root, and E is the error allowed in the answer. Y0 is substituted as f of x0, y1 is substituted as f of x1, and I is initialized to 0. So if both the signs are same, then we stop the algorithm there and we write that these values are not suitable. But if they are not, then we continue for the while loop that checks x1 minus x0, x1 is greater than error or not. So x2 is substituted as x0 plus x1 by 2, which is our midpoint. Y2 is given the value of f of x2 and I is increased by 1. Then again, if sine y0 is equals to sine of y2, then x0 is given the value of x2 and x1 is given the value of x2. Here we end our while loop. We write the solution converges to a root. We write the number of iterations that are required as I. We write the values of x2 and y2, and here the algorithm stops. So I hope this video lecture was beneficial for you. Thank you and have a nice day.